Okay guys, so I'm going to have a little look at an exam paper question on um, complex numbers. Again, this is quite a typical exam paper question. I can't remember what year it is now, I'll find out. But it has this z1 is equal to minus 2 plus 3i, so that's your real number and your imaginary number. Z2 is equal to minus 3 minus 2i, so again, you have your real number and your imaginary number. And it has z3 is equal to z1 minus z2. So we have to formulate z3 ourselves. It gives us a rule, I squared is equal to minus 1, which we will use a little bit further down. So it says plot z1, z2 and z3 on the Aragon diagram. Label each point clearly. So this is very, very easy, particularly for z1 and z2. So z1 minus 2 in the real numbers, right? Plus 3i there, so we are here. So that is z1. z2 minus 3 in the real numbers, minus 2 in the imaginary. So that is z2 there. And finally, we need to plot z3. But in order to plot z3, you need to work out what it is. And I'm told that z3 is equal to z1 minus z2. Well, in this case, to work out z1 minus z2, I'm just going to put them in brackets to be safe. z1 is minus 2 plus 3i minus z2, which is minus 3 minus 2i. Now this minus is going to change the signs here. It's going to begin with minus 2 plus 3i. Minus and a minus give me a plus 3. Minus and a minus give me a plus 2i. I can add together things that are similar. So I know that 3i plus 2i gives me 5i. And I know that minus 2 plus 3 gives me 1. So I'm left with 1 plus 5i. And I can plot that now. So z3, you're going to need that a little bit later on, is 1 plus 5i. And what I can do is I can go across the 1, up to 5i here, and I've got z3. Now I'm going to scroll down here, so I'm just going to write to the side what z1, z2 and z3 is. So z1 is minus 2 plus 3i. z2 is minus 3 minus 2i. And and z3 is, as we got here, 1 plus 5i. Get rid of this here. I'm going to move on to part 2. So, part 2 has these little lines here, which is my distance, or my modulus. And remember, the modulus is the square root of the real number squared plus the imaginary number squared. So it's my real and my imaginary parts put together squared. So it says investigate if z3 is equal to z1 plus z2. So the modulus of z3 is the same as the modulus of z1 plus z2 put together. Well, let's just work out the modulus of each of them. So start off with z3. So z3, I'm going to do, as you see here, 1 plus 5i. So it's 1 squared plus 5 squared. That's going to give me square root of 26. z1. Well, z1 is minus 2 plus 3i. So it's going to be the square root of minus 2 squared, which is going to give me 4, and use a calculator for this, plus 3 squared. And don't forget to put them in brackets. So that's going to be 4 squared there, plus 9 squared is equal to the square root of 13. And z2. z2 here is minus 3 squared plus minus 2 squared. And again, that's going to give me the square root of 13. So it's saying the square root of 26 is equal to the square root of 13 plus the square root of 13. Well, is it? Now, this one caused a little bit of confusion. So what I would do is I would change them to decimals, because then you definitely know. So the square root of 26, when you change it to a decimal, is 5 0.09 is all equal to the square root of 13. You change it to decimal is 3.6, and it's going to be step 1, 3.6. And as you can see, 5.09 is not equal to 3.6 plus 3.6. So 5.09 is not equal to, in this case, 7.2. So they're not the same. And people see this and think, oh, they are the same because 13 plus 13 gives you 26.